Internal assessments. If we're going to undertake environmental moisture assessments, the first thing we need to do is there's the visual assessment, and this is of course undertaken at the time of the and visual evidence of dampness. Well, there's a simple comparative table. I'm not going to read it, but you can read that for yourselves. It gives you all the differences between condensation, rising damp and penetrating damp. And of course, condensation is effectively seasonal, most commonly between September and April. So what do we do visually? Well, water droplets on impervious surfaces, glass, paint, tiles, plastic wallpaper. Impervious surfaces show the condensate up as liquid water. It's come off on your hands. If the surface is permeable, such as some plasters and so forth and paper, you may not see it to start with. It doesn't particularly look damp unless it gets very severe. In this case it was severe. Here it is on paper, the lower part of a wall. That area up to about 1 metre was below the dew point, and it occurred in all the flats. More visual assessment. It's a bit of a serious one, this one, but there's plenty of water around to see, caused by surface condensation. More here. Quite interesting, this one. On the upper left we have a photograph that's lining paper, distinctly wet. Indeed, there was water running down the wall, but virtually no mould. And the photograph on the right shows condensate on the base of a party wall, which is pretty extreme. Fairly obvious again. There's some water run marks above the window, and somebody in that place smoked. Here again, the 4.5 inch part of the wall, that was condensate soaking into the finishing plaster. It did not occur on the thicker part of the wall. Corrosion runs past nails. All of these are obvious signs of condensation and water running. Subfloor condensation can be very serious, often a cause of dry rot, lack of subfloor ventilation. And this is rather an interesting one. It's the effects of cold mortar beds in the gable end of a roof. The condensate was forming onto the colder mortar and soaking into the lightweight blocks. More condensation, been condensating on the lining and then soaking into the timber. So those are the visuals. The next thing one needs to do is to collect information about the property, building itself, ventilation, number of occupants, times of occupied, insulating, heating, history of the problem. And then we start recording data. We can record data at the time of the inspection, surface temperatures, air temperatures and humidity, inside and out. Recorded data. This was from a snapshot. We've got this data. We've measured the air temperature, relative humidity and vapour pressures, and we have the wall surface temperatures and the calculated relative humidity at the surface temperature. Notice at the base of the walls it's getting over 70. In one case, in the bedroom, it was over 80. Why? The base of the walls are colder. We can see that from the wall surface temperatures. So, and the vapour pressure, we see at the bottom, differential vapour pressure, internal minus external, was very good. It was 0.39. But again, I'll emphasise again, note the elevated relative humidities of surface temperatures at the base of the walls. They are colder, hence the relative humidity. We can collect long-term data, temperatures inside and out, relative humidities inside and out, wall surface temperatures, and we've seen how to do this earlier on. And we need to analyse the data. It needs to be appropriately manipulated. For example, this is just a straightforward temperature humidity in relation to a room, bedroom I think in this case, yes, and mould risk to exposed goods such as leather and cloth, because we were getting mould growth on the bedclothes. But look at the relative humidity. It's running up around about 90%. That will allow mould growth on certain items and certainly on certain cloths. We can do differential vapour pressures, which we've mentioned earlier on. This case it's very high. We would expect an average of about 0.5. That's the maximum expected average, but in this case it's running much higher. It's running up about 0.7. So we have a ventilation problem. And again, relative humidity at the surface temperatures. Remember, surface temperatures of walls are usually colder, and we have here risk of mould to the surface in the external wall. RH is running again somewhere just below an average of 90. However, if we take the internal wall, the relative humidity is down just below 70. It's much warmer, and we can see that from the temperatures as indicated in red and black, or rather red and green along the bottom. And once we've got all this information, visuals and so forth, we collate all the data, including your visuals, and make your conclusions and recommendations. So what about relative humidity or vapour pressure? Well, we use relative humidity for condensation assessments, internal environment assessments, risk of mould, moisture in timber. Remember, timber is a hygroscopic material. It absorbs atmospheric moisture quite readily, and indeed hygroscopicity as a whole. And here I'm really thinking about salt damp caused by hygroscopic salt contamination. We can use vapour pressure or other factors, absolute humidity or mixing ratio, to assess the potential change in the internal environment over a period of time. And we could also use it in some cases to determine what is dry after flooding.